Okay, so welcome back. And so today what we're going to do is we're going to do some examples of putting complex numbers into trigonometric form and vice versa. So the first two examples, we're going to take these and we're going to transform them into trigonometric form. And then the last one is we're going to go the other way. We've got a complex number in trigonometric form. We're going to put it back into the standard form. Okay, so let's start with the first one. So what do we have here? We have -4 plus 4i. So again, remember it's going to be in the form r times cosine theta plus I sine theta, where r, again, r equals the square root of a squared plus b squared. Why? Because r is the distance the point is from the origin, which is the definition of the absolute value of a complex number. Okay? So, immediately r is going to equal what? Well, it's a squared plus b squared, right? So it's going to be equal the square root of -4 squared plus 4 squared, which is then going to equal what? 16 plus 16, which equals the square root of 32. Okay, and we can simplify that. Right? So we've got 16 times 2. So that will give us 4 times the square root of 2. So then we get 4 root 2 times what? Well, that's it. It's just going to be cosine theta. Now, now we have to figure out what theta is, right? Okay, so how do we find theta? Okay, so I'm going to erase this here for a second. Okay, so remember how we find theta. If we have the right triangle, and we saw that we have A, B, and R, and we have theta, well, we need to figure out what theta is. And the way to do that is, well, we know A is equal to R cosine theta, and B is equal to R sine theta. But that's not really going to help us. Okay? So let's use tangent. So tangent theta equals what? Opposite over adjacent. So it's going to be B over A. Now remember, what's that? Well, it's negative, it's 4 over -4, right? 4 over -4, which equals -1. Okay, now we just have to figure out, okay, the tangent of what angle equals -1? Well, what quadrant is tangent negative in? Tangent is negative in the second and fourth quadrant. And in this case, we're going to get 4 pi over 3. Or excuse me, 3 pi over 4. Okay, so the angle that gives us the tangent of what angle equals -1, in this case is going to be 3 pi over 4. Okay, because remember, oh, here's another thing to keep in mind. What kind of angle gives us a tangent of 1? A tangent of 1 is going to be what? It's one, these two sides are the same. Well, that's going to be a 45-90 triangle. So we know that this interior angle has to be a 45 degree angle. Okay? So that will also help us with that. So in this case here, this implies that theta is equal to 3 pi over 4. Okay, which is in the second quadrant, right? And that makes sense here too, that we know it's in the second quadrant, because if you look here, this is A, so that's going to be 4 units to the left, and then 4 units up, so it's just going to be in the second quadrant. Okay, so it makes sense that also supports this answer as well, 3 pi over 4. Okay, so now we can finish up. So that means we're going to have 3 pi over 4 plus I sine of 3 pi over 4. And that's our final answer. Okay, now, what about the next one? Well, we're going to do the exact same thing, right? So now we've got our A and B. So again, R. So R equals the square root of A squared plus B squared. And so A is 2. So that's going to be the square root of 4 plus, and B is this. Okay, so we're going to take the square root. Okay, so what is the square root of 2 root 3 over 3? Well, that means, remember, the properties, the properties of exponents is going to be, we're going to use the power property, so we're going to distribute the power, the exponent, to all of the factors in the quotient here, okay? And, well, the product and the quotient. So we're going to distribute across the product and the quotient. So this is going to give us 4 times 3 over 9. Which then this 3 is going to cancel with, this is 3 squared, right? So this is going to cancel with this 3, so this is going to give us 4/3. And so that's R. Or excuse me, that's this part right here, 4/3. Okay. So now we simplify this. Well, this is going to be the square root of what? It's going to be 12 thirds plus 4/3. Oh, look at that. So we're going to get 16 on the top, which is a perfect square. So we're going to get 16/3. So the square root of 16/3 is going to be 4 over the square root of 3. Well, we can't leave it like that. Remember, we cannot have a square root. We cannot have a root in the denominator. Okay, so we're going to rationalize this. So we're going to multiply the top and the bottom by root 3. And so our final answer is going to be 4 root 3 over 3. And that's R. All right, so now I'm going to erase this. Now that we have R, I'm going to erase this, give me some room. So 4 root 3 over 3. Now I have to find theta. So again, I'm going to use tangent. Theta equals B over A. which is going to be 2 root 3 over 3 divided by 2. Okay. Well, I can see that this 2 and this 2 are going to cancel. So this is going to cancel with this. And so I get root 3 over 3. Okay, so now if you're thinking about this, you can maybe notice what angle this is, because now we're going to ask what the tangent of what angle will give me root 3 over 3. Well, this is also the same as 1 over the square root of 3. So if you remember, this is like the unit circle, right? So if you're thinking of the unit circle, 1 over the square root of 3, right, is what kind of triangle? That's a 30, 60, 90 triangle. Okay? And we're talking about tangent, so the opposite over adjacent is 1 over the square root of 3. And so what do we know about this? This is going to be 2, right? It's a 30, 60, 90 triangle. So that means, guess what? This is the 30, because this is the larger, this is the smallest side, this is the next side, of course this is the largest side. So guess what? The smallest angle is across from the smallest leg, so that's this one, so this has to be a 30 degree angle. Which is what? Pi over 6. Now, tangent is positive. So tangent's positive in both the first and third quadrant. Okay? So I'm going to say, oh, by the way, well, just look at this. This is positive, right? So well, you know what quadrant is. Again, look at this form. So this is what? 2 units to the right. And then 2 units down. Hold on, I made a mistake somewhere. Where did I make a mistake? Oh, that's right, negative. This is negative. Oh, so this is negative. I'm sorry. So yes. Okay. So now, so we're looking at the second and fourth quadrant, and so obviously this is in the fourth quadrant. We can see that it's in the fourth quadrant. And so now, this is pi over 6, but it's in the fourth quadrant. Okay? So negative pi over 6. Well, we don't want to use negative angles. Okay? So what would we use? Well, again, we use the coterminal angle. So if we're out here, and this is pi over 6, or negative pi over 6, then we would use, this is theta. Okay? And again, going all the way around is 2 pi. Okay? So 2 pi, okay, which is the same as 12 pi over 6, and we subtract off one of those 1/6 pi over 6, we get 11 pi over 6. And so that is going to be our angle, 11 pi over 6. So we're going to use theta is equal to 11 pi over 6. Okay, so again, negative pi over 6 is the same as 11 pi over 6. Okay, so now we're done. So now it's just going to be cosine 11 pi over 6 plus I sine 11 pi over 6, and we're done. Okay, last one. Well, now we're going to go the other way. So we need to put this in a plus bi form, standard form. So how do we do that? Well, if we look at cosine 4 pi over 3, so let's go back to our triangle. So we know this is A, right? So R, A, B. And so we know A is equal to R cosine theta, but R is here. Okay? R is 4. R cosine 4 pi over 3. Okay, where R is 4. Okay, so that means A over 4 is equal to cosine pi over 3. Okay, well, we don't even need to go that far. Think about this. Cosine of 4 pi over 3. What is cosine of pi over 3? Where is 4 pi over 3? Well, this is in what quadrant? Right? So this is your A. Well, not really A. It's not A. It's A divided by 4. But that being set aside, all we need to know is what's cosine of pi over 4 pi over 3. Well, what angle? Where's that angle at? Well, this is going to be a 60-degree angle because pi over 3 is 60 degrees. So I'm doing 4 of those. So, well, 3 pi, right? 3 pi over 3, that's going to be 180 degrees. That's going to be right here. So we are right here in the third quadrant. So theta is right here. So 4 pi over 3 is here, and this is a 60-degree angle. The reference angle is 60 degrees. Okay? And so that means for a 60-degree angle, cosine of a 60-degree angle is what? It's adjacent. So that's going to be 1. This is going to be the square root of 3. And then this is going to be 2. So what do we get? We get adjacent over hypotenuse. So this is going to be 1/2. Now cosine in the third quadrant is what? Negative. So this is going to be negative 1/2. So far this is going to be equal to negative 1/2 plus, now, what's sine? Sine of that angle is going to be what? Opposite over adjacent. So that's going to be the square root of 3 over 2 times I. All right. Guess what? We're pretty much done. So all we have to do is multiply through by 4. And we're done. Oh, hold on. This is negative 2. I forgot. This is negative. Oops. Okay, so now just distribute through. And if I distribute through, This is going to be 4 times a half, so that's going to be negative 2. Minus 4 times, again, I'm going to get the same thing, so I'm going to get a minus 2 root 3. And this time I'm going to put the I in front of the root. So it's going to be 2I root 3. Okay, or if you want to put 2 times the square root of 3i, that's fine too. But that's it. That's in standard form. Have a great day.